Irrational numbers. Numbers that cannot be written in the form p by q, where p and q are integers and q not equal to 0. That cannot be written in the form p by q, where p and q are integers and q not equal to 0. Examples are root 2, root 3, pi, etc. Theorem: let p be a prime number. If p divides a square, then p divides a, where a is a positive integer. If p divides a square, then p divides a. Theorem: root 2 is irrational. We have to prove root 2 is irrational. Let us suppose that root 2 be a rational number. Let root 2 be a rational number. So you can write root 2 as a by b, where a and b are co-prime and b not equal to 0. We have to prove root 2 is a rational. For that, we are supposing root 2 be a rational number. So if it is a rational number, we can write root 2 as a by b, where a and b are co-prime numbers. Co-prime means no common factor except 1. 1 is the only common factor of these two, and b not equal to 0. So from here we can write root 2b is equal to a, taking b to the other side. So 2b square is equal to a square, squaring on both sides. This means that 2 divides a square. This implies 2 divides a square. Using the previous theorem, we can write 2 divides a. 2 divides a. If 2 divides a, we can write a as multiple of 2, 2c for some integer c. Substitute this in equation 1. So 2b square is equal to, instead of a square we can write 2c whole square. So 2b square is equal to 4c square. So b square is equal to 2c square. This means that 2 divides b square. If 2 divides b square, we can say 2 divides b. So 2 divides a and 2 divides b. So 2 is a common factor of a and b. But we have supposed that a and b are co-prime numbers. Only one is the common factor. But here what we got is 2 is the common factor of both these. So this is a contradiction. So what we can say is root 2 is irrational. Since we have supposed root 2 is rational, we got the contradiction. So what we can say is root 2 is irrational. We have to prove root 2 is irrational. For that, what we have supposed is root 2 be rational. So if root 2 is a rational, we can write as a fraction root 2 is equal to a by b, where a and b are co-prime and b not equal to 0. Then root 2b is equal to a, squaring on both sides, we are getting this 2b square is equal to a square. So this means that 2 divides a. If 2 divides a, we can write a as a multiple of 2. A is equal to 2c for some integer c. So 2b square is equal to 2c square. Finally what we got is b square is equal to 2c square. This means that 2 divides b square. 2 divides b square implies 2 divides b. So 2 is the common factor of both a and b. This is a contradiction. for A and B are co-prime numbers. So our assumption is wrong. We can say root 2 is irrational. Next is example 9. Prove that root 3 is irrational. We are supposing let root 3 be a rational number. If root 3 is a rational number, we can write root 3 as A by B, where A and B are co-prime numbers. A and B are co-prime and B not equal to 0. So from here we can write root 3b is equal to A. So 3b square is equal to A square. This means that 3 divides A square. 3 divides A square implies 3 divides A. So we can write A as multiple of 3, that is 3c for some integer c. So 3b square we can write as 3b square is equal to 3c whole square. 3b square is equal to 9c square. So b square is equal to 3c square. This means that 3 divides b square. 3 divides b square implies 3 divides b. So 3 is the common factor of both A and B. This is a contradiction because we have suppose A and B are co-prime. So our assumption is wrong. What we can say is root 3 is irrational. Next is example 10. Show that 5 minus root 3 is irrational. If this question carries 3 marks, first we should prove root 3 is irrational. Prove that root 3 is irrational. If it is a 3-mark question, root 3 is irrational. You have to write the proof of this. If it is 2 marks, no need to write this. You can start like this. Let 5 minus root 3 be a rational number. 5 minus root 3 be a rational number. So we can write 5 minus root 3 is equal to A by B, where A and B are co-prime and B not equal to 0. So we can write this as 5 minus A by B is equal to root 3. I have taken this A by B to left, so 5 minus A by B, and root 3 to other side, so it is root plus root 3. So taking the LCM, we can write 5b minus A divided by B is equal to root 3. Clearly this is a rational number. 5b minus A divided by B is a rational number. This is a rational number means root 3 is a rational number. This is a contradiction because we have already proved root 3 is irrational. So our assumption is wrong. So what we have supposed is 5 minus root 3 be a rational number. So we can write it as A by B, where A and B are co-prime and B not equal to 0. Then I have rearranged the terms and I got 5b minus A by B is root 3. Clearly this is a rational number. So this means that right side is also a rational number. Root 3 is a rational number. That is a contradiction because root 3 is irrational. So our assumption is wrong. What we can say is 5 minus root 3 is irrational. Next is 3 root 2 is irrational. If this is of 3-mark question, first we should prove that root 2 is irrational. 2 marks, no need to write this. Then start, let 3 root 2 be a rational number. If this is a rational number, we can write this as a by b, where a and b are co-prime, and b not equal to 0. So keep this root 2 on one side and all other terms to the other side. So root 2 is equal to a divided by 3b. I have taken b to the other side. So root 2 is equal to a by 3b. Clearly a by 3b is a rational number. This implies that root 2 is a rational number. This is a contradiction. This is a contradiction because root 2 is irrational. So our assumption is wrong and we can say 3 root 2 is irrational. Exercise 1.3, third question, first subdivision. Prove that 1 by root 2 is irrational. So first step is let 1 by root 2 be a rational number. So we can write 1 by root 2 is equal to a by b, where a and b are co-prime, and b not equal to 0. So we can write root 2a is equal to b. Squaring on both sides, we are getting 2a square is equal to b square. Equation 1. This means that 2 divides b square. This means that 2 divides b. So we can write b as some 2c for some integer c. So this equation is 2a square is equal to b square. Instead of b square, we can write 2c whole square. So 2a square is equal to 4c square. That means a square is equal to 2c square. This means that 2 divides a. 2 divides a square. That implies 2 divides a. So 2 is a common factor of both a and b. This is a contradiction to our assumption that a and b are co-prime. So our assumption is wrong. 1 by root 2 is irrational. The question is prove that 1 by root 2 is irrational. Let 1 by root 2 be a rational number. So we can write it as a by b, where a and b are co-prime and b not equal to 0. So from here, rearranging the terms, we are getting root 2a is equal to b. So 2a square is equal to b square, squaring on both sides. This implies 2 divides b square, implies 2 divides b. So we can write b as some 2c for some integer c. So substitute that in equation 1. 2a square is equal to 2c whole square. So 2a square is equal to 4c square. So a square is equal to 2c square. This implies that 2 divides a square. That means 2 divides a. So 2 is a common factor of both a and b. This is a contradiction because we have supposed that a and b are co-prime numbers. So our assumption is wrong. 1 by root 2 is an irrational number. So homework, exercise 1.3, first question, second question and third question, second and third subdivisions.